welcome back. I'm Jessie. I'm here at the Wolfram Tech Conference 2017, and for those that are just tuning in, I'm just talking with interesting people who are using our technology in pretty cool ways. I'm here with Abrita, and she's going to tell us a little bit about what she does here at Wolfram and what she's doing here at the conference. So,
okay. Yeah, so I work in the Wolfram Technology group, and so we do two kinds of things primarily. We provide technical support to users of the Wolfram technology, and that spans a huge spectrum of users from different areas. And so it's interesting trying to help out people. One day you're working with someone in academia who is using this for some hardcore physics or mathematical research, and then the other day you're working with someone who's a web developer and is trying to deploy stuff in the cloud and they need some help. So that's one aspect of the work we do at technical support. I work alongside a team of very talented engineers from very different backgrounds, from computer science, applied math, and nuclear physics.
Really?
Yeah, we do have someone, and fantastic to work in that team. And on the other side, I work for Wolfram Training. I'm trying to work with Wolfram U, that's up and coming. We are trying to put together courses that people will find useful and helpful, where we apply Wolfram technology, but we also want to help people out to learn whatever it is they want to learn, whether it's just basic math or data science or image processing or neural networks. So we try to talk a little bit about the topic, and then we bring in how you can use Wolfram technology to do all this stuff.
So Wolfram U kind of hosts a wide breadth of kind of topics that span from introductory language courses to image and all these specific areas.
Deep learning and using neural networks.
Oh, cool.
Yeah.
Cool. So what are you doing here at the Wolfram Tech Conference specifically?
Right. So I taught a course on data science. We broke it up into two parts. So we had one part in the morning and one part in the afternoon. The idea was to introduce people to the notion of a pipeline that you sort of a project workflow to go through a data science project from beginning to end, and show how you could use Wolfram Language. It's perfectly poised to be used in a data science pipeline, because we can do everything from getting the data into the system to publishing stunning visualizations or deploying apps on the web. You can do it all in the Wolfram technology, and so we want to highlight that aspect while giving people tips and tricks that are useful in a data science project.
So do you have a visual of the kind of prototype to deployment pipeline that kind of happens in a data science workflow?
Sure. So this is one of a picture of the pipeline that I shared with the attendees at my course, and I wanted to show that this is one version of the pipeline. This is how I see it. Of course, there are so many other versions, depending on your project workflow. You might want to do something first and something later. But this, I suggested that you start out with a question that you have that data can help you answer, and then you go out and collect data for it. Or you might already have some interesting data and you want to think, what interesting questions can I answer with the help of this data? So you start out with your question, you get the data in, and so then you start off on the pipeline. So you start with a phase that's called wrangling the data, because real world data is messy.
Oh yeah, definitely.
And a lot of the people who are in the course, they completely agree that we've had trouble, and data scientists really say that they spend almost 80% of their time in this phase, which is boring, but has to be done before you can go on to the interesting part of making your model. So
I love that it's called, I'm from Texas, so to wrangle data, it just makes me think of a rodeo, that you're just grappling with these these values and just kind of...
Exactly, that's the picture, because a lot of time it's just hacking away at it, because you don't know what's in there, you want to put it in the right format. So you start out with data wrangling, and then you go into data cleaning. You want to get rid of errors and missing data. A lot of times stuff is not there, and you have to come up with a plan how you're going to replace it, or you just want to throw it away, stuff that has missing data in it. So then you go into that, and then you go into exploratory analysis, because a lot of times before jumping into modeling, you want to, kind of find your, find which way things are going, get like a picture of the data. I mean, literally look at the data, make a graph out of it.
Yeah, just try different things and play around with the data to see like what kinds of things you can use.
And sometimes you come up with interesting questions at that phase that, hey, I never thought of this, but I can see this in the picture. So that would be exploring. And then you go on to modeling, pre-processing, more theoretical stuff that, we have established technology for.
What is pre-processing? I don't really know much about how it works versus processing data versus cleaning it up.
Sure. So for example, if you're working with images as your primary data, you can't just work off the images, a lot of times. So if you're doing things like machine learning, things like clustering, where you want to find, how close certain images are. So there comes the notion of distance between the images. Now, how do you calculate a distance between two pictures? Right. So you convert the image into numerical vectors. So the images become numbers.
Oh, I see.
Basically the pixel values, right? So
I didn't know that had a name. Pre-process.
So you have the vectors, and now you can calculate the mathematical distance between them with something as simple as like the Euclidean distance function, or anything more complicated that is specific to your need. But now this step where you're going from the image to a number vector, this is pre-processing, this is feature extraction. And we have a great function for that. We have the feature extract function, and we have some variations of it. And I try to talk about that in my course. It's like quick and easy way where you don't have to write your own code. You use a feature extract function, and you can go from one form of feature to another. And then also there's dimension reduction, which is very important in machine learning and data science, because you're flooded with data. You have lots and lots of features. You can't possibly use all of it. You want to get it down to a reasonable, way that you can handle. And then also, if you want to look at the data, you want it in 2 dimensions, right? You cannot plot it in 5 dimensions, so 2 or 3 dimensions. So that's where dimensionality reduction comes in, and we have functions for that. So you can quickly, and we have established algorithms built in that you can use, and you can dimension reduce.
So it seems like this whole high level process kind of it's decreased with the amount of sort of automation that.
Yes, that's the idea, that you want to automate as much as possible.
Gotcha.
Because you want reproducible research. You want to run this pipeline over and over again, and so that's why we are, we are saying that build a pipeline, automate it, script it, write as much code as you can. Don't go like point and click and download and So
okay. Now I kind of understand what Etienne was talking about yesterday with the fully automated data scientist. This is kind of what he had an example of like a baker and a pie, but this kind of is a little bit more concrete and makes a little bit more sense.
Okay. Yeah, and then just to end the pipeline, of course, you have to validate and make sure your model is doing what you hope it would do. But at the end of it, which I feel is really important, is to tell the story. Like, you can do all the analysis, but it's not useful if you can't get your message across. Right? And to get your message across, you want an efficient and actually sometimes a beautiful way to do it. You want a pretty picture that someone can look at the picture and they know what you're trying to tell them. And that's where our technology comes in so nicely, because we can make really good visualizations, and it's all in there. You get the data and the results of your analysis. You make these quick, nice, beautiful plots, whether it's just a trend, or it's the evaluation of your model, like a confusion plot matrix. It's anything like that.
Sure, I know a confusion. I know exactly what that is.
Yeah, and I was actually sharing an anecdote at my course that when I was in graduate school, just to make that confusion plot matrix look nice and share it with my advisor, I spent 2 days coding it, and then I used our machine learning function, and when we just provide it as an option. We say, okay, confusion plot matrix, and boom, it's there. It's so much easier. So anyway, not just visualizations, we also have technology for standalone app like a Cdf Technology. And also, I was saying that if you want to deploy your little classifier on the web, so you can deploy it as a cloud object. And so we have this little microsite. And actually, for my course, I used the example of classifying recipes based on ingredients. And so what I did was I created a tiny site where you just type in the ingredients, and it will classify the cuisine. and then I put in a link to like a recipe website, so then it
Oh my
gives you
God.
a suggestion to, okay, if this is the ingredient in your pantry, then you can cook probably.
Oh my God, that would be so helpful for me. I mean, I live in a house with a bunch of other people. We're required to cook at least once a week, and half the time, like, I don't even know, like, I get into the kitchen to cook, and it's like, what do we have? And then I figure out what we have, and I'm like, I don't know what to make.
What to make with it.
Yeah, exactly. Oh man, this would be so helpful to have just like on hand.
So that's one way of actually, you do all the analysis. That's one way you put it out into the world for people to use. So
Right.
that's what you call creating a data product. And that's like at the end of your pipeline. So, this is how I'm telling the story of classifying the cuisine of the, with the ingredients. And so now I have the actionable insight that is you cooking. You're getting stuff out of your pantry and, using the product to cook. So.
Oh, I love that. Man, that is so helpful. You mentioned Cdf Technology. Can you tell me, well, just in case like our viewers don't know what Cdf is, can you kind of talk a little bit about it and how it's like useful in this sort of like process?
Yeah, and they have had a few talks at the conference, and I think they'll have one more right after in a few minutes about CDF. CDF stands for Computable Document Format. So where it's like, living documents, where it's not just like static papers, but you actually have code and interaction built into it. So you can have like sort of a GUI where you can play around with it. So if you have created an analysis for publication, now it doesn't have to be flat. It can be interactive. So you can have controllers on the GUI. So whoever is consuming the result of your research, they can play around with parameters, change things, and see how the analysis is changing. So
yeah, I can see how that's super important for data science in particular when they want to reproduce. You can just like you get the document and it'll run, and you can kind of actually see how it was.
Things change.
Yeah. Cool.
Okay.
Thank you so much for talking with me, Abrita.
Sure.
I appreciate you taking the time out of your schedule.
Sure.
And like,
thank you for having me.
Yeah. Well, like always, if you have questions about this particular discussion with Abrita or any others, just leave them in the comments of this live stream. We can't get to it during this time, but someone can get back to you later. Also, community.wolfram.com is a great resource. If you have any questions, someone might have already had it. You can also pose your own questions and then start a discussion. And definitely check out Wolfram U if you're interested in any of these these data science courses or image processing. There's a lot of new interactive courses being uploaded in the near future, so definitely check that out. And thanks for watching.
Okay.